Welcome to the Explainer. Today we are tackling, well, probably the biggest question you could ever ask. How did everything begin? And we're going to look at how one of the most powerful tools we've ever built might just give us the answer. You know, for thousands of years, this question belonged to philosophers, then physicists. But something is changing. A completely new era of discovery is dawning, and it's being powered by the absolutely incredible evolution of artificial intelligence. So, this journey of discovery, it's probably going to happen in three big phases. Each one is marked by a huge leap in what AI can do. We'll see it go from being a specialist tool to a full-on creative collaborator, and then finally, something like an oracle. All right, let's get into it. So first up is NAI. This is where we are right now and for the next few years. Think of NAI, or artificial narrow intelligence, not as a thinker, but more like a superhuman extension of our own senses. It's basically the most powerful, most precise tool we've ever had for studying the cosmos. And it's already doing some heavy lifting, tackling huge challenges that are honestly impossible for us to do on our own. It's filtering out cosmic noise from the oldest light in the universe. It's mapping out billions of galaxies to see the big picture. It's speeding up physics simulations like you wouldn't believe, and it's listening for these incredibly faint gravitational waves. What's the common thread here? Well, it's basically clearing away all the static so we can finally see what's really going on. Okay, so let's take a perfect example, the cosmic microwave background, the CMB. People call it the afterglow of the Big Bang. It's literally the universe's baby picture, the oldest light we can possibly see. But here's the problem. That signal is so faint, and it's buried under all this other interference, like dust from our own galaxy. The analogy is perfect. It's like trying to hear a tiny whisper during a hurricane. And this is exactly where NAI comes in. It's a total game changer. Its deep learning algorithms can look at that messy signal, figure out what's noise and what's real, and just perfectly remove the noise. Suddenly, we can see these tiny patterns, these echoes left over from the universe's first moments. And that really shows you its power, right? NAI isn't coming up with the theories itself. It's just giving us the crystal clear data we need to build. So look at this. The change is just massive. What used to be manual data processing is now automated and happens in real time. Simulations that would tie up a supercomputer for months? Yeah, AI can do those in seconds, using something called surrogate models. They're like these brilliant shortcuts for crazy complex calculations. So the big takeaway here is that AI isn't finding the final answer. It's just clearing the way, making it possible for us to even ask the right questions. Okay, so that's the tool. Let's see what happens when the tool starts to think. Okay, phase 2, AGI. Sometime around 2030, things are expected to get really interesting. The whole relationship changes. AGI, or artificial general intelligence, stops being just a tool we use. It becomes a partner, an actual intellectual collaborator that can reason right alongside our best and brightest scientists. The difference is just night and day. AI is a calculator, a really good one, but it just follows instructions. AGI reasons. It can pull together knowledge from different places and form its own ideas. It's a shift from just crunching numbers to actual thinking. Imagine it connecting the dots between, say, quantum mechanics and general relativity, these two giant pillars of physics that we've struggled to unite for a century. AGI could find the hidden links we've been missing all along. So how would it even work? Well, first, it would absorb everything we know, all of it. Then it would start asking, what if, on a massive scale, generating millions of new hypotheses. And here's the really wild part. If it comes up with an idea, but we don't have the data to test it, AGI would then propose brand new experiments or even design the exact kind of telescope we need to build to go get that data. It's a complete research cycle, done by machine. I love this quote because it just nails it. AGI is the parallelization of Einstein's brain. Just think about that for a second. Take the genius, the creativity, the intuition of someone like Einstein. Now imagine thousands of him, all working together 24/7 on one single problem. That's the kind of intellectual firepower we're talking about with AGI. It's just staggering. And then we get to the final leap. Maybe around 2040, maybe later. This is ASI, artificial superintelligence. And honestly, this is where our language starts to break down. It's an intelligence so far beyond our own that the best word we have for it is an oracle. So what would an oracle like this even do? Well, its goal would be to solve the holy grail of physics, The theory of everything, a single, beautiful framework that explains, well, everything. It's a problem that stumped the greatest minds for 100 years. And here's the thing, AI won't just use our math to solve it. The prediction is that it will have to invent entirely new kinds of math, concepts that we can't even imagine right now. And how would it find the answer? Get ready for this number. It could run 10 quadrillion simulations of the entire history of a universe at the same time. It's basically reverse engineering creation. It would run simulation after simulation, tweaking the starting conditions each time until one of them perfectly matches the universe we live in today. It could even test whether other universes are possible, the whole multiverse idea. It's just mind-bending. I think this chart just sums it up perfectly. You can really see the evolution. Our role changes. With A&I, we're the astronomer using a tool. With AGI, we're a physicist working with a collaborator. And with ASI, we become humanity being guided by an oracle. And look at the questions. We go from asking how galaxies form, to asking why dark matter exists, all the way to asking the ultimate question, why does the universe exist at all? So you step back and you look at this incredible journey, from a simple tool to a partner to an all-knowing oracle. What does that actually mean for us? Where do we go from there? This quote really gets to the heart of it. The answer that ASI gives us, it won't just be a science thing. It could be the first scientific answer to the oldest philosophical question there is. Why is there something instead of nothing? It would bridge this huge gap between science and philosophy, giving us a data-driven answer to something we've only ever approached with belief or logic. And maybe that's the real takeaway here. What happens when AI actually solves it, when we finally know how the universe began? It might feel like the end of the line for physics, but maybe it's not. Maybe getting the answer to the biggest question we've ever had is just the beginning of a whole new chapter of questions we haven't even learned how to ask yet.